Hello everybody, I am Rafia Sabih and currently I'm working for Cybertec. And today I'm going to talk about something very interesting to do with Postgres and how do you extend further but with more innovation. So this talk is interesting only if you are more of an experiment, something that you have never done before and which involves learning a new language. For instance, for here it's like Golang. So maybe you're writing Postgres extension, you already have some Postgres extensions and you want to extend it, add more feature, but maybe you're just bored with C, or maybe you want to do something more intelligent in the sense that you want to write less code, more efficient code, and you want to do it in maybe Golang. Then this is an experiment that we did and at Cybertec, and I will encourage you to do yourself and we'll learn many more things there. So going a little bit about what Cybertec is doing. So Cybertec has this main feature or main product, which is PGEE, which basically is based on, it's like mostly Postgres, but with the addition of a few other things, and primary of them is TDE, transparent data encryption. So like that, there are many other extensions that are available with the Cybertec, and I chose my experimental ground to be one of them, which is called PG Deep Thinker. So what it does, it's kind of an advisor that runs in your system and checks for like what are the things that are going wrong in your database. Are there some performance bottlenecks? Are there some poor SQL codes that you are running? So it takes care of a large range of things actually, starting from like checking for key configuration parameters like the size of shared buffers, the status of auto vacuum, the parameters related to it, or if like max parallel workers, partition wise join, if it is enabled, disabled, how are the things there, FPWF sync. So all those key parameters. That is one part of it. And another more interesting part for this particular talk is actually reading through your queries and seeing if you are not running very efficient SQL there. For example, you have some unused or missing indexes. That is not really poor SQL, but it's like poor schema in itself. Or if you are writing queries which have like joins, but there is no join condition, that is you are forcing your optimizer to choose Cartesian products. You are inserting without column names. We know that if you are doing it and it is part of some script, then if you like change your schema a little bit, things can go really bad. Or for example, using of limit without order by. So in such cases, you will of course get results very differently at different instances. So all these type of things, it keeps on like running, and it tells you about these things that these are the issues. So as I said before, that for this part of our talk, we will only focus on the second part of this extension, and that is detecting and advising for poor SQL. So what you can see is that mostly it is just, checking for different patterns, like if there is select distinct, if there is limit without offset, limit without order by, delete without where, or join without join conditions, something like that. Basically, it's reading a lot of SQL queries. And to give you a more like a feel of it, how does it do and what does it output in that sense, these are some example advices that it gives. For example, if it is insert without column names, so it will also give you the like parameterized query where it went wrong, so that you have all the more detail and you will not just go searching it here and there. And also sometimes it also points you to some links or some tutorial where you can learn more about that issue in further reading. If you want to provide some additional advisory script or something, that is also something that it does. So, and this is the example for join without join condition. So it specifically checks if there is no join condition, not just like there is no where clause or something, but so it's also like not very dumb. I mean, it's kind of a junior DBA. It's a type of a thing, like just like starting point of it, that all these like low hanging fruits can be easily, handled. So what we have seen so far is that we have a lot of queries that we are reading and making sense of it. if you think it in a little bit more code-wise way, we just have very long strings, and we are trying to find certain constructs there, and not just some constructs, but also like what is their order with respect to other constructs. And then if they are having certain pattern to it, if it is like, and sometimes it is also important to know like what is the total number of those constructs in that particular string. For example, if there are too many union clauses, so that's also something that is not a very good practice per se. And also if you are using in-list, but it has like lot of values in there, then also it might not be an efficient query. So the sense that we make out of it is like we have to read a lot of strings and like get some constructs from them and see their pattern and things like that. I mean, I'm just explaining this so much so that like most of us know C and we can comprehend that. It's not very intuitive to do it in C. And it's just becomes too verbose. So this is one example, which is not even this full code for this particular issue, but it will just to give you a feel that how like complicated it gets in C when you do especially string processing in that way. And the other thing that you can notice that even when you're finding the pattern that there's a select, limit, offset, that's also very primitive. It's not really nicely done and not in any way efficient. So that was the initial thing that I started with, and this was the code that we ended up with. So this is just to motivate you to just be awake, and we can continue to know how we can do this. So that all 10, 15 lines of code can be reduced to actually 4 lines of code. And that too, not with many, you are not using many things per se. It's like just few packages, not even few, but like just one of the packages and the usual functions that Golang provides. And in that way, you can reduce your code. And also, when we are building a tool like that, in which we want to, of course, keep on adding to it, we want to make it all the more sophisticated, then we cannot start with that like very verbose code, which after some time, even developer forgets like what is going on here. It takes another 15 minutes to, just go through it. So that is the one motivation that we thought of actually extending this part of this extension into Golang. And the other motivation is because I knew only Golang and it was a task assigned to me. So yeah, we'll start with there. So the way we did it is like the main thing that I needed to learn or understand here was the CGo package. It's basically a package provided by Golang, and it does all that bridge work of making Go code compatible with C code, in the sense that when you call in C the Go code, it will able to understand like what it is, and it will all that bridge work that the code written in Go could be understood by the C callers is done by this CGo package. So that's the primary starting point here. And the next thing to make our job all the more simpler is we used libpq query package that is like available in C itself. And that is something that is used, I think, in many other contexts also. Basically, it's a thing to parse your query in a JSON format. So instead of having just like a string, we chose that it will be easier to do it in JSON format. And now at the Golang side, what we did is found like which is the good package that can read and parse and help us in reading this JSON text. And we found one that is called GJSON, basically. So here are a couple of examples like how it does is it has some very sleek functions, which is called like dig function. So basically you provide like what is the field you are looking for in that JSON, and it will just tell you if it is present and what it is and the value of it. And similarly, if you provide the JSON path, then also it will like tell you if it exists and like what is it. So, and yeah, the rest of the things that we were able to do was with the help of like the efficient handling and the like very non-verbose code of Golang by just using its array and string and like the similar things. So this slide particularly is there to tell you that to start this, it's really not challenging. You don't need to learn many tools or anything, but just install Go and set up the respective environment variables, and you are good to go. So it's really that easy. There is not much preliminary work that has to be done. There is no particular tool that has to be learned. It's quite simple. So how do you start with is like you write a Go file in which you do all the logics that you want to do in Golang. And the interesting part is that this Go file is special in the sense in the preamble of this particular file, you can add any C library if you want to include in any way you want to use it in this part of the code. You can include it in the following format, like as a comment, and also any other special C flags or LDD flags that you need for compiling for this particular part of the code, as with this cgo directive. And also, which I wasn't, in my problem, it was not required to do, but you could actually write the C code in this Go file, which you require to use in this particular Go module. For example, if you want to have some special structure, which you can define in C, for example, some typed F something, you can do it in as a comment section here, and can actually use it in that Go code that you write below it. So that's also something that you can do, but in my problem it was not required. So now the next part is that we write the C code that sorry, not the C code, but the Go code that is to be called from the C code. And the way to do it is add this export comment with the function name. So for every function that you write as this, will be compilation wise, it will be known that, okay, these are the functions that will be called from C. If you do not do this, then they are only just local Go functions, and it can be called through Go part only. So once you compile this Go file, that's when you get the magic. So now after compiling this, it automatically creates a C header file. And in this header file, it will declare all these functions that were this especially written with export as the external functions in C. So now all this part is included in your C header file. So your C compiler will just understand, okay, this is some code that is defined somewhere. And also any special structure or any special data types that Golang has, for example, string, etc., that is also defined and declared in this part of the code. So now your C also understands what is Go string as a special type, and the magic is that you don't have to worry and you don't have to write anything, you don't have to declare what is Go string, etc. But what you have to do is actually you have to write a function to convert your array, character array, to Go string. So for example, in this case, because now we very well know what is Go string, because it has already given us the definition here in that header file, we can just write a small function that, okay, anytime you get this, you return this. That is the character array. So that's a little bit work that we have to do. And now we'll go to the C part of the things. So here we'll just, call our Go functions like any C functions. And whatever helper function that we have created, with them, without them, as per the requirement. And at the Go side of the things, we really don't have to write this conversion thing there, because there we have C package, which already does it for us. So for example, when we want to return any data type of we want to convert it, in Golang, we have strings. So we want to return that string to a C code. Then we don't have to write anything, but we already have this in C string in the C package. This is a function which you can just call, and it will convert your Golang string into the character array, which will be easily manipulated by, or can be read by, your C code. So it's just one way that we have to do. So now the other part is that how do we make it finally compilable is actually change to your extension make file. So you add all this Go build directive there. One thing that we have to note here is that although Go has many different Go build modes, but for this particular case, when we use CGO packages, we can only build in C shared or C archive mode. So what it means is, like when we built it, we require one main package, and of course you cannot have more than one package. But what it also means is that any package which is like not main but is not called directly by main can also not be built by these build modes. That is something to be kept in mind, that we can only build like one big main package. Anything that you want to do in Go, that has to be called in C. So it will be just one main package, and anything that it calls, like the main package, main functions calls from another package, those all can be built, but you cannot have like any X package which can be directly called from C code. So that's the important part. So that's all of it that you need to do. Like once you have decided what you want to do, those are the like really easy 4 steps to do it. Now, of course, why do we need to do it? So as you have seen it previously, that it improves the readability. It's like very easy to extend the code, much less effort once you have learned Golang, of course, and much easy to test, not in the sense of test suites per se, but like in the sense of the amount of code that is there. So yeah, and for our case, it's like our extension improved overall, because now we can extend many, we can have many different patterns that it can check and go through now. So it's not really much difficult now to add code to this particular part. But yeah, it's not all golden. So the first thing to keep in mind is like it will increase the size of your extension, because now it has to be built with all the dependencies and the Go build packages. So for our case, like we have this GJSON package. It was small, but if something bigger is required or more than one package is required, something more complex you are doing, so you have to keep in mind that it will get heavier as like a package thing. And also this communication between C and Go is like not very, it's not very unrestrictive in the sense, because all the fun of Golang is there, that you have all the like very fun data types and everything. You cannot really pass directly that to your C code, because C of course will not understand, even though there is some interface to do it. But it's just basically, it will be just some pointers that will be returned, and then the manipulation and reading, it's not as straightforward. It imposes many risks in that sense. So how it ends up is like you are ultimately using just int and character arrays as like the arguments to the functions or return values to the C code. So it basically reduces to that after all that. So unless your problem particularly requires that you use like some map of Golang which makes it more efficient, and that is the only way you can return to C code, then this might not be a good route for you. But if it is something like for our case, that we can do all the manipulation in our Golang part, in the sense we can read all the query, like if it has this construct, if it follows this, if it is like that, this and that. And then ultimately we can just return one string that, okay, this is following this pattern, and it's like you can advise for this particular thing. So in this type of scenario, it was very productive to do, because really you don't you don't require to return anything complicated here. So that is the biggest drawback, but otherwise, as you can see, it's very, very easy, and we have time to actually build one more feature with it in this as a part of this whole presentation even. So yeah, that's the efficiency of Go when you extend it. So yeah, but this whole presentation is intended to spark a particular idea that like we don't need to just struggle with the C. There are other frameworks that we can utilize to extend and learn. So I hope this was informative.
You had two modules, C, Go, and G, JSON. right?
Yeah, do packages.
Do packages. What was the GJSON for?
GJSON for all the JSON reading. For example, all these functions that you are seeing here, that I explained here, that we have this dig. So if you pass a JSON text to that and you provide a parameter in this dig function, it will just tell you if it is present in that, like for example here, if it limit is present in the JSON text or not, and if it is present, what is the value. So any field you can pass to that JSON, or for example, if you're searching for a path, for example, if you're searching for a from path, it's like it follows a certain way, right? If it is a from path, or sub-select, that type of things. So you can pass the path and it can just tell you, like in this one line, you can just write it and it will tell you if it is present in this JSON.
So to me, it sounds more like string pattern matching.
Not really pattern matching. I mean, it actually follows this JSON structure. So if in pattern matching, see, if you provide a delete path and delete anywhere is present, it might be just a match. But if you are searching for a delete path and you have defined it way, like first is delete, then from, then this. So if it is, yeah. So if that pattern is not, thank you very much. So if that path is not matching, then of course it's not the thing. It has all the more many such things, but these are the two things that I used most in my work. So I pointed out this, but it's very interesting actually to do like to look at this GJSON. You can actually just if you have like, for example, how do I say, if you have like a JSON with the names of people or something, and you just want to find the people with the last name this and that, so it can actually go and search if this is the last name of the person whose the first name is this, or all the person with the last names like that. So it's, you can reverse the things there. So there are like, yeah, many interesting things. And that's like something that reduced the number of lines of code drastically, because otherwise if you do even in Golang just the JSON reading by yourself, it's not that efficient.
This is really interesting. Can I see the slide where you export the symbol definitions from Go?
This one?
Yeah, there's these ones. So you're returning. So if I'm calling a Go function and I want to return like 2 integers followed by 2 strings, could I do that?
No.
So it's always just one.
Yeah, it's always just one.
Basically returning like 1 integer.
Yeah, you can. Yeah, that's the drawback of it. That either you are just returning a pointer to like maybe integer also, like 1 integer array, or maybe 1 character array, but you cannot have like an array which is like something special, have some characters. Not like that.
But I can return a pointer, so you could return a pointer too.
Yeah, you can return a pointer, and actually in that sense you can also return things a little bit more complicated, but they will also be just pointers, right? So when you receive it at the C end, you have to like really know that this is the only way it will be read. Like for example, when you're passing that, you know that it is a map from Go, so you will read it that particular way. So that can be done. In that header file that Go compiler creates, it defines all these special structures like this Go string, map, Go map, or even Go int, because Go int has certain extra like ranges and has some unsigned things, little bit more than C. So all those extra things that are not in C, it defines there and declares there. So you can actually see and then decide like if you want to, if it is easy for your purpose to create a conversion function, write a conversion function, then you can do that. It will just return that. But yeah, there is another thing that you have to see, that the C import that we are doing in Go. So if that C, that like I have written c.car, so it should have, that C package should have a pointer for that, have a data type. But I think it is there for most common data types if you're talking about like these maps and all.
If you have errors in these comments, do you get proper error reporting out in the logs? Like when you're compiling your Go file, will it be?
Yeah, of course. Yeah, of course. When you are compiling your Go file, you will have an error. And, I mean, depending on the issue, it might be more convoluted in the sense of like the error message. But yeah, any issue there, because you can also, as I told you, that we can also write like after this include, you can also actually write the actual C code. So anything going wrong is of course read here and understood here. So yeah, you will get the errors. It shouldn't be an issue. Okay.
Thank you.
Thank you.